10.4 calculating area and perimeter of irregular shapes. I can find area and perimeter of irregular shapes.
Excellent. Thank you, Nick. Today our goal was to find area and perimeter of weird shapes. Number one was, I'm going to outline in green. You started off with what you see in blue here, which I'm now outlining in green. And I asked you to find the perimeter, but I did not give you this, and I did not give you this. You guys came up with that on your own, right? Can somebody quickly explain, how did you come up with the number 3 here? How did you know that that was a 3? Maren?
5 minus 2.
This side right here is 5. This side at the top here is 2, right? So then this must be 3 because 5 minus 2 is 3. And then the same thing here with the 6. Yes, no? Okay, we knew that the long side on the left here was 8. We knew that the tiny little short part right there was 2. 8 minus 2 is 6. Excellent. Add up all the sides, you got your perimeter. Yes, no? Second thing we did then is we did some chunking of the shape to find the area. Because you do not have a nice polygon, or what you can use base times height, we made our own polygons, right? So this became a 2 by 2 polygon, and this became a 6 by 5 polygon. And right here you can see we did the area of the top little shape that I made an X with, and we did the area of the bottom bigger shape that I made another X with. Yes, no? Add them together and you have your total area. Second thing we did is we plotted some points. Again, we did some chunking to find area. You guys had to come up with your own dimensions by just counting the boxes, right? Okay, and then perimeter, I gave you none of the dimensions, you just counted. So you got 8, you got 6, you got 3, you got 2, and so on and so forth, right? Last one then, super irregular shape. Can we make polygons out of that?
No.
No. And generally speaking, when you see questions like this, they're going to be on graph paper because there's really no other way to do it. And so what we did is we used the strategy that you see over on the right side. We found the area of the whole square, so everything in blue. So here's step 1. Everything in blue is a whole square, right? And how many do we count?
17.
And then we took all of the things you see in red, so all of this red stuff, which I'm now making green. We combined the partials to make wholes, and how many did we come up with?
6.
And then the last step was to add them all together, and we found the area of this weird looking like lake. I think it kind of looks like a lake, don't you guys?
Yeah.
Sure. And we found it at 23 units squared. And then if you had answer choices, you would find the answer choice that is closest to your estimation, right?
Yes.
Any questions?